Percentage runs through half the maths paper and most of data interpretation, so getting fluent here pays off everywhere. The good news, it's one idea. A percent is a fraction of 100, applied in 3 common ways. Let's take them one at a time. A percent is just 100th, so x% of n is x over 100 times n. But the fast way from our equivalence lesson is to swap the percentage for its fraction. 20% is a fifth, 25% is a quarter. Recognize the fraction and the multiplication becomes a division. To find a percentage change, divide the change by the original, not the new value, and multiply by 100. To apply a change, multiply. A 20% rise is times 1.2, a 15% fall is times 0.85. Increases multiply by more than 1, decreases by less. When changes happen one after another, multiply the factors, never just add the percentages. 500 up 10, then up 20 is times 1.1 times 1.2. 660, and a 20% rise followed by a 20% fall is 1.2 times 0.8, which is 0.96, a 4% loss, not 0. The trickiest type works backwards. If a 20% cut leaves a salary of 4,000, then 4,000 is 80% of the original. So divide, don't multiply. 4,000 over 0.8 is 5,000. When the question gives you the value after a change and asks for the original, you divide by the factor. Subscribe if this is clicking. 8 questions. 1. See there how it's thin van the head. It kindness. Decide first which kind it is. Simple, change, successive, or reverse. 20% of 350. 20% is a fifth, and a fifth of 350 is 70. Recognizing the fraction beats multiplying by 0.2 to 3. 20% is a fifth, so dividing by 5 beats multiplying by a decimal. Lean on the fraction equivalence from the conversions lesson constantly. 45 is what percent of 180? 45 over 180 is a quarter, and a quarter is 25%. Part over whole. Then convert. For what percent is A of B? It is always part over whole, then convert. Here a quarter is 25%, a fraction you should know on sight. Increase 250 by 20%. A 20% rise is times 1.2. 50 times 1.2 is 300. Or add a fifth of 250, which is 50. A 20% increase is the same as adding a fifth, so you can add 50 to 250 directly without touching decimals. Way decrease 400 by 15%. 15% of 400 is 60. So the result is 400 minus 60, 340. Find the 15% first, then subtract. Splitting it into the percentage step and the subtraction step keeps you from slipping. A number rises by 25% to become 150. The 150 is 125% of the original, so divide. 150 over 1.25 is 120. This is a reverse percentage. The value given is already after the change, so you divide by the factor, never multiply. 500 is increased successively by 10% and 20%. Multiply the factors. 500 times 1.1 is 550, times 1.2 is 660. Never add the percentages. Successive percentages multiply, they never add. 10 and 20 do not make 30. The factors 1.1 and 1.2 give a different result. 1000 rises 20%, then 20% times 1.2, the final value times 0.8 is 0.96. So 960, 4% net loss, not zero. Up then down by the same percentage always loses because the fall applies to a larger base. The net here is a 4% loss, not zero. After a 20% cut, a salary is 4,000. The original salary is 80% of the original, so divide by 0.8, 5,000. Another reverse problem. 4,000 is 80% of the original, so dividing by 0.8 recovers the starting salary. 30% of 90. 30% is 3/10, so take 10% of 90, which is 9, and multiply by 3 to get 27. Breaking a percentage down into the unit 10% and scaling up is often quicker than reaching for a single multiplication. Increase 80 by 25%. 25% is a quarter, and a quarter of 80 is 20, so increasing 80 by that gives 100. Spotting that 25% is just a quarter turns the whole problem into adding a quarter with no decimals involved. One idea, 4 moves. Swap percentages for fractions to find them fast. For change, divide by the original. For successive change, multiply the factors. And to go backwards, divide. Name of the type first, and percentage questions stop fighting back. The 20 question practice set is next. Subscribe, and I'll see you there.